Hi folks, and welcome to this presentation exploring the effectiveness of moderate intensity continuous training, also known as steady state exercise, versus interval training on body composition. First, let's clear up a few definitions. For moderate intensity continuous training, this is when we begin to exercise. In about 2 to 3 minutes, we'll reach a steady state in our oxygen consumption. Intensity is typically less than 80% of your VO2 max, and because of the relatively low intensity, we can continuously exercise over a long period for a single bout. Now, interval training can be classified as exercise performed in multiple short bouts, interspersed with recovery periods at a low intensity of effort, or complete rest. Interval training is often subdivided into high-intensity interval training, HIIT, and sprint interval training, SIT. When we are performing HIIT, the bursts of high-intensity efforts are typically above 80% of your VO2 max, whereas for SIT, the exercise portion of your session is maximal. In other words, you are doing an all-out sprint for short periods, typically less than 30 seconds, which are interspersed with low-intensity recovery periods, or just simply complete rest before the next interval. Both steady-state exercise and interval training have shown benefit in improving body composition. However, there is a lack of agreement as to whether one type of exercise is superior to the other. To try and answer this question, James Steele and colleagues conducted a systematic review and meta-analysis. A meta-analysis is the highest form of evidence-based research that aims to systematically assess previous research studies to derive conclusions about the area of research. In this case, steady-state exercise versus interval training to determine which is better for body composition. Is it slow and steady or hard and fast? James Steele and colleagues analysed 54 training studies using a range of different participants, which varied in duration from 4 to 52 weeks, that compared the effects of interval training and steady-state exercise on different measures of body composition. For example, skin folds, hydrostatic densometry, or bioelectrical impedance. This presentation, brought to you by Talking Sports Science, will be a summary of their research findings to determine which is better for body composition. Is it slow and steady or hard and fast? We are now going to look at the outcome of 4 key measures. The first measure, changes in fat mass. It is often mentioned that interval training may be superior for fat loss benefits compared to steady-state exercise. However, the results of the meta-analysis found interval training and steady-state exercise were similar when it came to reductions in fat mass. When compared to non-exercising controls, there was only small reductions in fat loss, which were minus 0.25 kilograms for steady-state exercise and minus 0.22 kilograms for interval training. It should be highlighted that none of the studies that included control conditions combined exercise with a dietary intervention to help promote a calorie deficit, therefore suggesting that exercise alone only induces a small amount of fat loss. This can partially be explained due to the relatively low level of weekly exercise time across the studies. For example, within the studies analysed, steady-state exercise ranged between 48 to 250 minutes, and for interval training ranged between 3 to 120 minutes. Furthermore, participants may have increased their calorie intake during the training weeks, which may have also impacted the results. Therefore, more extreme volumes of exercise may be necessary to induce meaningful changes in fat loss, irrespective of the intensity of effort. Although exercise may play an important supplementary role in the fat loss process, the findings highlight the importance of dietary prescription. Moving on to the second measure, changes in fat-free mass. Researchers speculated interval training may provide sufficient stimulus to enhance muscle growth, particularly in middle-aged and older adults, as well as clinical populations. However, the results from the meta-analysis indicate that endurance exercise intensity and duration do not mediate hypertrophic adaptations. Therefore, under the methods employed, across the studies analysed, neither interval training or steady-state exercise offer any benefit to affect fat-free mass. Consequently, those who believe that endurance-based exercise is a viable interventional strategy for promoting muscle hypertrophy should think twice about sending out this message. Moving on to the third measure, exercise adherence and dropouts. It has been argued that the intensity of effort during exercise influences one's emotional response, and that this is predictive of future intentions and behaviour towards exercise. Adherence to steady-state exercise and interval training was similar and relatively high, with both steady-state and the interval groups of participants completing approximately 90% of sessions, with the dropout also being similar and relatively low, at approximately 13 to 17%. It should be highlighted that both steady-state exercise and interval training were supervised, and it is well established that programming and supervision provides positive effects on exercise adherence. Therefore, these findings can't be generalised to self-directed exercise programs. Nevertheless, it seems logical that giving individuals the choice of training intensity would likely help to improve long-term exercise adherence. The fourth and final measure, adverse events. Of the studies reporting adverse events, there were no differences between steady-state exercise and interval training, suggesting both are safe in the population studied. However, most studies failed to report instances of adverse events, and so future studies on interval training and steady-state exercise should track and disclose any that occur, so that we can better understand the risks associated with each exercising strategy. Key points. In the long run, going slow and steady or hard and fast has minimal influence on longitudinal changes in fat mass and fat-free mass. Therefore, from a practical standpoint, personal preference is key. Individuals can choose steady-state exercise or interval training, or a bit of both. If you're wanting to achieve favourable changes in body composition, it is recommended and much easier to create an energy deficit from dietary restrictions, in conjunction with performing steady-state exercise or interval training, to support a calorie deficit. Thanks for listening, folks. This presentation was brought to you by Talking Sports Science. See you next time.